My name is Matti Putkonen, and my home university is University of Helsinki, and I'm an associate professor there, working as a field of the atomic layer deposition and etching. ALD is a method to make thin films, and it's based on the surface chemistry and surface limited reaction at the surface. So we need a detailed understanding of what kind of chemical precursors is reacting at the surface. But also for applications we need understanding of what kind of properties thin films have and how they are behaving at applications. And this joint project is now concentrating on understanding the growth itself at the surface. ALD has plenty of different applications. They can be renewable chemistry, solar cells, fuel cells, for example, lithium batteries, and of course traditional thin films you can use in optics. Nowadays it's a mainstream technology, for example, in microelectronics and novel nanotechnology applications. Thinking microelectronics and microprocessors, there are constant need for ALD there, so it's not possible to make a modern microprocessors without ALD at the moment. All of those are based on the same similar chemistry, and we need a good working ALD chemistry on there. We need this kind of project that we understand what kind of chemistry is happening at the surface. In that sense, we are building up the collaboration with the Lund University and University of Oulu. And of course, the main aim is to develop such a tool that we can make atomic layer deposition in such conditions, ambient pressure conditions, that we can actually use the XPS at the same time. So we are developing the suitable cell for ALD that can be installed in these facilities. This setup now, this cell that has been built is dedicated so that ALD is done at 1 millibar pressure, and we can still measure, for example, XPS measurements there. So they are more like resembling the true ALD conditions. So we are making ALD at the optimal pressure range. Typically, ALD growth analysis is done either in situ or ex situ. And for example, our university is doing plenty of ex situ analysis for thin film deposition. In situ technologies are only measuring after one pulse what happens at the surface. But now we have a possible to make a constant analysis during the deposition. So once we are introducing the chemicals on the surface, we see right away what happens at the surface. This is bringing something new, because now we have possibility to analyze the growth process in operando, so we actually see what happens during the pulses of the ALD. This week we are studying the ALD processes. We are concentrating on different noble metals because they are quite tricky to deposit by ALD, and we want to get a better understanding. Of course, we want to know more and more all the time, so we have plans to send more students and come here again for additional measurements.